Yeah? Okay, okay, go. Oh, you're already going? Okay, thank you. All right. So, trig number 4. Right? Trig number 4. What does trig stand for? Trigonometry. Good. I'd write it out, but it's too long, so I'll write it out. Go ahead. I'm getting too lazy. Trigonometry. All right, trigonometry. And basically it's the study of angles, but that's kind of a paraphrase of the meaning of it. And a lot of times people will ask you, if once they find out you've done a geometry, they'll say, how did you like trig? Because it's oftentimes considered a very difficult topic. I would say it's one of the 2 most difficult. At the same time, a lot of my students do very well in trig. So it's kind of maybe sometimes it's fun to do well in a difficult topic at times. So what shape does trig deal with? What shape does trig deal with in geometry? Right triangle. And I'm going to say that for now because we will get into law of sines and law of cosines, and those technically are trig too, so those do not deal with right. But for the moment, it's a right triangle. And I'm going to draw this a little bit different today than I've drawn it before, just to mix things up a little. Let's draw it like this and this. There we go. Yes? Is she? Okay. Can you say for sure this is a right triangle? No. What do you need to see to know it's a right triangle? You need the little symbol. You need this symbol here. Right? Once you have that symbol, now even if I drew it badly, even if my angles weren't to look, this side's kind of slanted, but now you know for sure in your mind you can picture it as a perfect right triangle. That is with a 90 degree in this angle right here. All right, let's talk about the names of the sides. What's the name of this side here? Hypotenuse. Good. And I'm going to call it a hype, H-Y-P, hypotenuse. What's the name of this side over here? Leg. And this one up here? Leg. Good. And your memory devices, you go like this, with your hand, right? And you say, a right triangle has 2 legs like a. Okay, so that's the best I got. All right. Now, the interesting thing is that we then deal with these other 2 angles. So there's only 2 angles left. We don't, at this point, we know that's a 90. So we ignore that for now. We're looking at the other 2 blanks. We don't know the angle here. We don't know the angle here. That's called the reference angle, the one we select. And we're only going to talk about one at a time. So if we call this one here alpha, so now the reference angle is being put in this location. And so your variables for angles are what? Alpha, beta, phi, theta. Right? Where do these come from? Where are these letters from? Greek alphabet. Right? And for whatever reason, we've adopted, just from the origins of Euclidean geometry, we adopt these Greek variables for an unknown angle. Right? So you have alpha in there. If this is the reference angle, now this leg takes on an additional name, and this leg takes on an additional name. What is the additional name? So because this leg is close to the reference angle, what's the additional name that this leg gets? Yes. Why? You are correct, but why did your brain think that? Was it a total guess, or did you have some idea that that was the adjacent? And what are you thinking? What were you going on? What led you to say this has to be adjacent? Good. Good. That's exactly where I would love for you to go, and you went there. It's adjacent because in geometry, adjacent means next to. Right? So if 2 apartments are on the same side of the hall, we can say they're adjacent apartments, or the apartments are adjacent to each other. So adjacent is describing a location, and it's describing it in relation to this reference angle. In other words, if the angle were moved to here, that adj leg would move now. That adjacent leg would move. And I want to go through that now for this. If this is the adjacent leg, what's the name of this leg over here? OPP stands for opposite leg, and that's because we use opposite not to mean like short or tall. In geometry, we use it to mean across from. So if two apartments are on the opposite side of the hall, we're now using the word opposite to describe a location. We're going to say that apartment's on the opposite side of the hall. Fair enough? So we're changing the use of these words in terms of maybe your normal use. For geometry, that's what it means. So then quickly, let's rearrange. Let's take the same right triangle like this. Let's call this a leg and a leg. Whoops, okay. And then now let's move alpha to here. So we're changing the location of the reference angle. Once we change the reference angle to here, we're not worried about up here at the moment. We're worried about down here. This leg now becomes the leg next to the alpha. Does this make sense? So what's this leg now called? Adjacent. Okay, and what can often mix up students is, they're looking at this triangle, they look oriented the same way, and they're going, wait, that was the op leg. Why is this now the adj leg? And it's all about what the reference angle is. We move the reference angle, therefore the adj leg is now close or next to the reference angle, and this leg over here then becomes the op leg. All right, very good. Thank you for all that. Okay, what is the secret word or acronym that allows you to know all the 3 trig functions? SOHCAHTOA. The spelling is important. If you start to get the spelling wrong of SOHCAHTOA, then you start to go down the wrong path of what is the definition of each trig function. So here's what it is. It's SOH, and it's a so, it's a long O. It's ka, and it's a soft A. And it's TOA, long O, soft A. Okay, so everybody say SOHCAHTOA. What does the SO stand for? Or, what does the S in SO stand for? Sine. And I'm going to drop in sine alpha. Remember, your calculator is going to abbreviate sine sin. It's not that there's sin in math class, it's that was the easiest way to abbreviate the trig function on the buttons in your calculator. Sine alpha equals, what does the O stand for? Right here. What's the O stand for? Op is right, but what has to flow with the op? Op what? Keep it with the leg. Yeah, I'm just trying to say keep the leg on there. Maybe you were saying that too and I didn't hear it, okay? So keep leg. So this is op leg. That's what the O's for. What's the H for? Good. I'm going to try to do hype and try to write it. So that was our sine function. We did that in lessons in trig 1 and 2. And 3 and 4, we've been dealing with ka, or what does the C stand for? Cosine. And we're going to abbreviate that COS. We're still using alpha as a generic variable for the unknown angle. What does the A stand for? Adj leg. Good, thank you, thank you. I appreciate you guys going through this repeatedly. I thank you very much. And what's the H stand for? Do not forget the height. Okay. With that said, let's do 2 examples. Let's do 2 examples for cosine. Let's talk about, let's see. Here's one here. $29. This is 5, and this is a question mark. Is that what's in the notes? Yes, that's what's in the notes. First things first. At some point, you're going to be forced to choose between these functions. You're going to choose between sine, cosine, and when we get to it, we're going to have a third one, tangent. Right? Students will say, how do I choose? This becomes a difficult part in the beginning for you to struggle through. So they're giving us a reference angle, and then what side do they give us here? What's the name of the 5? The 5 is which side of the triangle? Here's the reference angle. This is adjacent leg. Good. Because this is an adjacent leg, you're going to use either sine. Nope, you're not going to use sine because, see, it's only got op leg in it. So we're not going to use sine. We're going to use cosine because it's got an adj leg. And when we get to tangent, it'll have an adj leg too. But what other side do they give us? What's the name of the one up here, the unknown? What's the side's name up here? What's this one called? What's the name of this one? What is it? Height. And so because we have an adj leg and a height, we're going to focus on the cosine function because it has those two sides in it. Does this make sense? Okay. So let's go ahead. Let's say cosine alpha, we'll write out the formula. Cosine alpha equals adj leg over height. And then we'll say cosine of. Now we have an angle, so we're going to drop that straight in. 29 degrees. The adj leg is 5. We do not know the height, so we're going to make that a regular variable x, regular as in it's the length of a side rather than the measure of an angle. Then we're going to do a little bit of algebra here. If we were remembering proportions, we could switch these directly. If we don't remember proportions, then we can multiply this side by x and this side by x. We can divide this side by cos 29 degrees and this side by cos 29 degrees. We cancel anything over itself other than 0 goes to 1. The x's disappear. The x says x equals 5 divided by cosine 29 degrees. And we say x is approximately equal to. All right, are you ready? Do you have your calculators? Can you do this without me? Try to do it without me telling you how to plug it in. And depending on your device, whether it's an iPhone or an Android, it's slightly different for you. Yes, start from the 5. Good. Good. The trig function you have to do backwards though. So you have to plug in the angle, then hit the function. Very good. Very good. Although that doesn't look right to me. Is that what it is? Let me think. Nope, it can't be right. It looked right the way you plugged it in though. I like exactly the way you plugged it in. Do it one more time, clear? Say 5 divided by, just like you did, 29 cosine equals. There, 5.72. That looks better to me. The other one was too small. It has to be larger than 5 because it's the hypotenuse, and that's the longest side. Okay, who got 5.71? Good. Jacqueline, did you try it? Did you get it, Marisol? Okay. And are you trying it? You're on that. Did you get it? Yep. Yes. Good. No. Plug in the angle. So it's 5 divided by this one of 29 degrees. Put that in there and you should get it. Okay, Marisol, did you take 5 divided by 29 cosine equals? Did you get it? Do 5 divided by 29 cosine equals. You got it? And so you see how it's backwards a little bit? You got to put the 29, then the cosine, then hit divide to get the 5 to divide by. Or hit equals to get the 5 divided by to execute. Yeah. Okay, I'm not saying it very well, but I'm trying to say it. Shaolin, how about you? Okay, good. Okay, and Natalie, did you get it? Do you still have your phone? Are you trying it? Did you get it? Did you try? Try. Turn sideways. So yours is going to be done more directly. Yours is going to say 5 divided by, and now do the cosine. Now type in the angle, 29 degrees. Now say equals. Bing. All right, let's do one more example. All right, let's say cosine alpha again equals adj leg over height. Cosine of, we don't know the angle in this case, so it stays alpha. The adj leg in this these are the two legs because they're attached to the 90, and it's the adjacent leg because it's next to. So it's going to be 5 over the height, which is 16. We're going to put the alpha here, move the cosine over, and it gets a -1 on it because it's going to be a reverse or a cosine or arc cosine. And then you have 5 divided by 16, and see if you can plug that one in. See if you can plug that one in. Go, Natalie, try that one. Do it again. Better. You have 5 divided by 16. Say equals. That executes the division. Good. Now do your second cosine to the -1. There you go. 71.79. 71.79. Does that make sense to me? 71.79 degrees. Okay, who got that? Did you get that one? Okay, you want to jump back to this? I'm almost done, like 30 more seconds and we'll be done with this. I just want you to keep trying to execute these because it's so different on your different devices. You got it, Shaolin? Okay. Yes? Okay, okay, good. And the other thing just to mention, you want to make sure your calculator is in degree mode, DEG, as opposed to rad or radians. We'll use that later in another class. We're using degree mode for now. That's the other thing. Mine gets flipped out into radian mode oftentimes, and then it gives me a strange answer right now. Did you get the result? So yours gets typed directly. You're going to say inverse cosine, and now just type in 5 divided by 16. Okay, did you get it? Okay, so, yeah, you got it, right? Natalie, last call. And you're typing directly now. You've got the inverse, perfect, so say cos, and just type in 5 divided by 16. Good, equals, done. Right? Okay.